Good morning, everybody. We'll get started here in just a second. Make sure everybody gets in. All right, everyone. Good morning. Happy Monday. We're happy that you guys are here with us on this Monday morning. Beautiful October morning out there. We're excited to start off this bi-monthly series. We're on our second one of this Certified Livestock Manager webinar series. Today, we're going to be focusing on manure sampling, treatment, and record keeping. We hope that this series can connect you guys with some key stakeholders, that you're able to focus on animal agriculture. We have lots of different topics planned. We are also going to be starting up our Water Quality Wednesday at the beginning of the year. That's going to run on the months that we aren't doing our CLM series. We have 3 speakers for you guys today, focusing on different manure related topics. So we are going to go ahead and get started here. So we have a wide variety of topics. We're going to look at how to collect a manure sample, what's in a manure analysis, interpreting your manure test, manure application, record keeping systems, manure treatment technologies, and then we're going to wrap up the end of today's session with any questions that you guys have. So today's speaker, we have Jason Hartschuh, who's a CCA. He's from our Crawford County Ag and Natural Resources Extension Educator. He's going to be looking at manure analysis and record keeping. Then we're going to go with Rachel Cochran. She is our Water Quality Extension Associate for Paulding, Defiance, and Van Wert counties. And she's going to be looking at one approach for manure application record keeping. And then Theresa Dirksen with Ag and Natural Resources Director from Mercer County, and she's going to be looking at reusing manure. So we're going to get started with Jason. And Jason, you can go ahead and share your screen.
All right, thank you for that introduction. We're going to talk a little bit as soon as I get, there we go. Thanks, Courtney. I had to get my screens rearranged so I could see my slides instead of all of our participants. It's great to have everybody here today. When it comes to manure, I'm going to start off talking a little bit about taking the sample, reading those manure tests, and then record keeping. Really, those are all critical steps to maximizing your profitability when you use manure on a farm, or as a custom applicator, maybe you're not using it yourself, but helping your growers understand the value of that manure, how to maximize its value, and understand how far they can haul that manure. We're not going to talk about that economic side today, but you have to understand how to use that manure test in order to show them the value of the manure, potentially show them the value to them of an upcharge for incorporation instead of just spreading it on top to help your operation. So to start with, we're going to talk about taking that manure sample. We're going to start with the minimum strategy. The minimum strategy is really not enough to get a high quality sample, but it's what it requires to at least get a sample you can have some confidence in. So when we start talking about manure and taking the sample, and then when we get into that manure analysis, there's really 2 types of manure we have to consider, that liquid manure and then the solid manure, because it's not going to work very well to use the same sample strategy for both. A flat tarp that we use for the solid manure isn't going to hold that liquid manure very well. The pans that you may use for liquid manure could work for solid, but it's still not as good. So when we think about liquid manure, we want to collect the sample from the field. We don't want to collect that sample by sticking a cup in the pit and dipping some out when we start or dipping some out at the end. We want that sample as agitated and homogenized as possible to what we're applying to the field. And as we'll see later, it's really important that we take samples at multiple time points as we're pumping that lagoon. Even if it's well agitated, these lagoons and manure pits are still not uniform from start to finish. And if we're only going to take one sample to represent that entire barn or represent that entire outdoor lagoon, that one sample needs to be a mixture from across that pumping time frame, or else we don't actually have a sample that represents what was applied to that field, because we're going to have higher and lower concentrations. So we recommend taking at least 5 samples. If you're just going to submit one of those, take and mix those together so you get a uniform mixture, and then put that into your sample bottle, and make sure you seal that sample bottle really well. Whoever you're shipping it through, whether it's the UPS or United States Postal Service, they will not be very impressed with you if your sample bottle begins to leak in their trucks. So make sure you seal that well. I often encourage people when they put it into that bottle to tape the lid so that it seals on and can't risk it coming loose. And then make sure you put it well wrapped in that shipping container, and don't just throw it in a box with no padding around it. When it comes to the solid manure sample, it's important again to collect multiple samples from the barn you're spreading from. If you're spreading out of a chicken facility where that's came out onto a conveyor, been put into a pile, and that pile's been mixed, it may be fairly uniform. Or if you're sampling from a manure storage barn, it may be more uniform than coming straight out of the barn. But often each barn with solid manure on our livestock operations, if we have different growing levels, if we have a beef operation, we have backgrounding pens, and then they move as they get bigger into finishing pens or dairy, young heifers into that breeding age are eating a different ration. They're going to be producing different manure. So we want to collect samples by facility, and then from different areas of that facility, because the manure from up around the feed line may be very different from back where they lay. So if we're just going to submit that one sample, we want to collect about 5 different samples from around that facility so that those can be mixed together to get us a good average of what we may be applying. One way to get really good samples and to do a better job of applying this manure is to do a calibration process while we are collecting our manure samples. To do that calibration process, encourage people to utilize a tarp of a known size. 6.5 by 8 feet is a common tarp size used for manure. And then we have to remember that there's 43,560 square feet in an acre to figure out what our multiplication factor is, or a 10 by 10 is even simpler. A 10 by 10 tarp, you just take that times 4,356 to get our pounds applied per acre. But you take that sample and you weigh each tarp load off a 10 by 10 and multiply it to figure out how many pounds of as applied or wet manure we're applying per acre. And we do that over 5 different spots in the field. Can get us a pretty good calibration along with collecting that manure sample. So we collect that manure sample. Solid manure, we want to make sure whatever container we're using or bag, we seal up well, and make sure again that when we pack it to send to the lab, we have paper around it. The plastic solid manure in the bag isn't quite as bad as liquid manure if that bag somehow gets broken, but we still want to be respectful of whoever we're shipping it to and not breaking those. So once we've taken those samples, we're ready to get those results back. But one thing we need to think about when we're thinking about how to use that manure and talk to our growers about is what their crop goals are, what their soil tests are, what our crop needs. If we're able to apply just a crop removal, we're going to look at that amount that our crop needs. So corn, I used some averages from last year from Crawford County. We had a 201 bushel corn crop. If we pull the tri-state nutrient removal rates, corn removes 0.35 pounds of P2O5 per bushel. So that's 70.35 pounds of P2O5 removed in that corn crop. Removes 0.2 pounds of K2O, so about 40 pounds of K2O removed. Using MRNT at nitrogen prices of a year prior, 185 pounds in nitrogen. and it removes 16 pounds of sulfur in that corn crop. Soybean crop had a 62 bushel average, is going to remove about 50 pounds of P2O, 71 pounds of potassium. We don't need to worry about the nitrogen removal because that soybean crop can fix its own nitrogen. About 11 pounds of sulfur. Now, if we go back to corn, if your growers are chopping corn silage, those are slightly higher rates because we're also removing that plant mass of nutrients removed. A 90 bushel wheat crop, it's going to remove about 45 pounds of P2O5, 22 pounds of K2O, 110 pounds of nitrogen, and 9 pounds of sulfur. You notice when I talk about these, I'm not talking about phosphorus or potassium. I'm talking about P2O5 and K2O, because that's what our nitrogen or our nutrients are calculated in tri-state. Those are slightly different than what the straight phosphorus or straight potassium rates are, because usually when we purchase fertilizer, commercial fertilizer to apply, it's in the P2O5 form or the K2O form. So to dive into the manure sample, so I'm going to have 3 different samples here to look at and review. Yours may be different than these. Make sure you run your own samples. Don't take our numbers from these samples from these growers and use them on your own operation because they probably are not correct. So for this manure sample, this is beef pen pack. That sample, when it was submitted, was fairly wet, so 75% moisture. And then as we come down, we have different amounts of nitrogen. So we have the ammonia nitrogen here. So the ammonia nitrogen is that fraction of nitrogen that can be easily lost. We're going to see some very different ammonia nitrogen rates based on type of manure and based on species. And then we have total nitrogen. So that is ammonia nitrogen plus your nitrates and organic matter nitrogen. And the thing about the ammonia nitrogen versus total nitrogen is the ammonia nitrogen is all going to be available in the first year. Our total nitrogen is going to be available over time. So if we come down, this lab, each lab is different. This lab is kind of nice in that they give us some of these calculations already done for us. When we look at nitrogen over time, so we have dry manure with bedding or pen pack manure, even though it's fairly wet, about 30% of the total nitrogen is going to be available in the first year, and then 16% in the second year, and then the residual is in the soil for years 3 and 4. It gets harder to calculate those longer term nitrogen availability. And then we have to look at another table when it comes to nitrogen. So we go back up to that ammonia nitrogen. It's about 0.02% ammonia nitrogen, or about a half a pound per ton of ammonia nitrogen. So we come over here, pounds per ton, 0.48 or about a half a pound of ammonia nitrogen per ton. But is that all going to be available? Come down here to the ammonia nitrogen availability chart. That ammonia is what's easily lost. When we look here, if we are not going to incorporate it right away, as often happens with solid manure, if we get it incorporated in less than 5 hours, about 90% of that will be captured in our soil. If it's a day later when we finally get it incorporated, 75 to 60% of that. So about 60% of that ammonia nitrogen is available from day 1 through day 3. If it takes us longer than 3 days or we don't incorporate it at all, only about 50% of that ammonia nitrogen is going to be plain available. So even on your solid manure and liquid manure, we have to really think about capturing and working with our growers to capture that ammonia portion of the nitrogen to maximize the profitability of that application and to get those nutrients in for our crop, especially on those spring applications where we will capture and be able to utilize some of Glenn Arnold's research has shown that nitrogen for our crop that year. Or if we're planting a cover crop, that cover crop can soak up that nitrogen. And another thing we need to think about, and I often tell growers, when you drive by your field and you smell that manure, it's not really the smell of manure, it's the smell of money leaving your operation, because a lot of that smell is that ammonia gassing off. We continue to look at this test. If we think about nitrogen, if we're going to make a 7-ton application, total nitrogen, that's 86 pounds, about 87 pounds of nitrogen we put onto the field. But in the first year, because so much of it is in that organic nitrogen form or nitrate nitrogen form, only about 27 pounds of that nitrogen is going to be available for our crop. So we could decrease, as long as we incorporate that manure right after application, we can decrease our commercial fertilizer usage by about 27 pounds of nitrogen. Then we go to phosphorus. In that 7-ton application, we're going to look at that P2O5 line because that's what our recommendations are in. Pounds per ton, 3.77 pounds per ton. So at 7 tons, 26.4 pounds of P2O5. Potassium. This manure sample is really high in potassium. We look at the K2O numbers, 22.58 pounds per ton of K2O. Take that times 7, we get 158 pounds of K2O. And then our sulfur, there's some work out there showing that we're getting closer and closer to maybe needing sulfur for our crops. Some of our forage crops, specifically alfalfa, are showing that response to sulfur more than corn, soybeans, or wheat do. But if you're looking at purchasing sulfur, you might as well calculate how much is coming out of your manure so you don't need to purchase quite as much. So 1.25 pounds per ton of sulfur. So that 7-ton application gives us 8.75 pounds of sulfur that we applied for our growers. So to kind of review that calculation process in a little bit more depth, specifically for the phosphorus side, most labs are going to report to you that P2O5 number because they know that is what our crop removal calculations are done in across the country. So when we look at this report, we have the lab analysis, P2O5. The percent is about 0.19% P2O5 in that sample. We don't need to look at the 1,000 gallons because this isn't a liquid product. If this had been a liquid product, we would look at this pounds per 1,000 gallons. But because it's a dry product, we're going to use the pounds per ton, which is 3.77 pounds per ton of manure we apply. So from the lab test of P2O5, pounds per ton, 3.77 pounds of P2O5 per ton, times our 7-ton application gives us 26.4 pounds of P2O5 applied per acre that we can take off of our commercial fertilizer application. What happens though when your results are in P or in straight phosphorus? It doesn't happen often, but there are a few labs that may report it that way. You can do that calculation yourself. So pounds of P, you take that times 2.3 to get that pounds of P2O5 to be able to utilize the tri-state crop removal as part of your calculations. Do all lab analysis look the same? No. This is a different lab. This lab reports things in a little bit different format. So we have the liquid manure sample. This is dairy manure. This dairy manure is 96% moisture, so it's a liquid manure. So we're going to be applying that per 1,000 gallons instead of by the pound. This producer has asked for a 10,000 gallon application, which for producers that work with swine manure sounds like a lot of manure to put on per acre. But when we look down across the nutrients, this is a fairly dilute product, and we're really not over applying. And we'll pull some numbers in another slide to look a little bit deeper at this nitrogen value, because when we look at this dairy manure, total nitrogen, 9.62 pounds per 1,000 gallons. So times 10,000, that's 90.62 pounds of nitrogen. Of that, about 80 pounds is going to be available for our crop that first year, as long as we incorporate it. So when we look at this sample, we have about 7 pounds of ammonia nitrogen, very little nitrate nitrogen, and then 2.59 pounds of organic nitrogen. So that organic nitrogen is going to be slowly released over 2 to 3 years to be plant available. Then we look, this lab does report both phosphorus and P2O5, so we want to use the P2O5 number to get us 20.9 pounds by taking the P2O5 times 10,000. And K2O, we want to use that, not the K number, so 15.22 pounds of K2O times 10,000, or times 10 for 1,000 gallons, because there's 10 in each 1,000, so 152 pounds. Sulfur concentration, about 15 pounds of sulfur we're going to apply. And this lab shows us a few more of the micros, so calcium, magnesium, sodium, sulfur, boron, iron, manganese, copper, and zinc. If you're purchasing those micros, you should really look at what your manure is applying for you, and maybe you won't need to purchase that micro pack to go on your corn or soybean crop either as a foliar or at planting, because you're getting that out of the manure. Liquid swine manure application back from that first lab, except for instead of looking at pounds per ton, we're going to look at pounds per 1,000 gallons. So to take it times 5, this is a really high nitrogen example. So there's 58.74 pounds of nitrogen per 1,000 gallons. So if we applied 5,000 gallons, we would apply 293 pounds of nitrogen. And most of that is in the ammonia form. So 43.43 pounds in that ammonia form. So this one's a really important one to get that manure incorporated so we can capture that ammonia nitrogen. If we don't incorporate that, if it's more than 3 days later, that cuts that in half. So we're about 20 pounds of ammonia nitrogen. So 20 pounds of nitrogen per 1,000 lost. Current nitrogen prices, that's about $20 per 1,000, or on 5,000 gallons, you're throwing away $100 worth of nitrogen by not incorporating that manure or putting it down in front of a crop or planting a crop to suck up that ammonia nitrogen. Instead, you're just losing it to the environment. Plant available, about 49 pounds plant available. The 58, since most of it's in the ammonia form, there's a little bit of organic that'll be released in that first year. So first year nitrogen, 247, because we can use from this report just this plant available number. P2O5, about 104 pounds of P2O5, pulling that off the 20.83 times 5. And then K2O, about 40 pounds of K2O per 1,000 times 5 to give us 201 pounds. Sulfur, there's quite a bit of sulfur in this sample too. 6.53 pounds of sulfur, or 32.65 pounds of sulfur. Typically, producers talk about applying 10 to 20 pounds of sulfur to a corn crop. And when we get to our crop removal slides, you'll see that this manure provided all the sulfur that corn crop may need. We definitely wouldn't need to look at purchasing additional sulfur. So using the manure in a rotation, that 201 bushel corn crop and 62 bushel soybean crop, across those 3 different samples, we applied 7 tons of beef manure, 10,000 gallons of dairy manure, 5,000 gallons of swine manure. How's that come at covering our needs? So from that corn soybean rotation, we would need 120 pounds of P2O5, 111 pounds of potassium K2O. If we apply it before the corn crop so that our corn can utilize all of our nitrogen, 185 pounds of nitrogen and 27 pounds of sulfur for that rotation. So when we look at the beef manure, we didn't meet our phosphorus needs. So we're going to need to apply more P2O5. We're going to need to apply some nitrogen, but we can reduce our crop removal rates by whatever our manure test was. So at 119 pounds of P2O5, if we take that 26 off, we're only going to need to apply right around 90-ish pounds of that P2O5 to meet our needs, 93 pounds to be exact. K2O, we've more than met our potassium needs as K2O. We put on 158 pounds and we only needed 111, so we're building that soil sum for potassium. Nitrogen, we didn't meet our nitrogen needs. We need 185 pounds. We only applied for that first year 27 pounds. If we have a multi-year rotation of corn, we could actually use some of that additional nitrogen credit and maybe reduce that rate a little bit more than just by 27 pounds. Sulfur, 8.75 pounds. So we'd only need over the rotation about 20 pounds of sulfur removed if we believed we needed sulfur. Come over to the dairy manure sample as corn. Nitrogen in the first year, we can cut our nitrogen rate in about half because we're going to apply 90 pounds and we needed 185 or 80. So we can go to 100. Sorry about that. Our P2O5, we didn't meet those removal needs because we only applied 20 pounds and we need 120 for the rotation. So we're going to need to apply about 100 pounds of P2O5. But again, with this sample, we don't need any potash. K2O, we applied 152 pounds, only removed 111. And we met 1 year of our sulfur needs basically with that dairy manure. Come over here to the swine manure, pretty rich, good stuff, 247 pounds of nitrogen. We could maybe have cut our rate back because we over applied on the nitrogen side because we only need 185, but we can definitely grow a corn crop that 247 pounds of nitrogen. P2O5, 104 pounds. So we almost met our P2O5 needs, slightly over applied, well, a lot over applied our K2O, so we're building potassium. That's part of that reason to move manure around so we don't build those soils too much, neither phosphorus or potassium. And we also exceeded our sulfur needs. Manure nitrogen availability, to dive into that a little bit more, this is a fairly handy table to have, especially if you're not using that lab that calculates plant available nitrogen for you. Look at that ammonia form, and the really important thing is if it's pre-plant and if we're going to incorporate it. If we incorporate it immediately, we should get 95% of that ammonia nitrogen to be plant available for our crop right after with that spring application. And then it kind of depends a little bit on air temperature with incorporation and timing after that. So with liquid manure, when the air temperature is below 50, we're going to use the middle column. When the air temperature is above 50, use the right column, and then solid manure is in the left column. So one day later, you're going to get about 50% of your solid manure, 70% of cool air applied manure, and 70% of warm air applied manure. But as we go down in time, that application gets worse. 7 days, if we don't incorporate our solid manure, we can count on about 0 of the ammonia nitrogen. Of the cool weather nitrogen in the liquid form, about 40%, because some of that has soaked into the soil. But in really warm weather or above 50 degrees, we may not get any of that ammonia nitrogen. So go back to that swine manure sample that had like 43 pounds of ammonia nitrogen. If that just lays on the soil surface for 7 days, we may lose all of that per 1,000 gallons. That's $43 per 1,000 at current nitrogen prices. And then the organic nitrogen available this year and in future years. So you first look at the type that came from. Most of our swine manure is not in a solid form, but if it is, about half or 0.35 for that first year. And then we can look at the years following. So the second year, you'll get about 15% of that organic nitrogen. It says the second year from now, but this is the third year, about 7.7%. And then in the fourth year, about 4% of that nitrogen will be available for your crop. Nutrient distribution during application. This is some work that we were doing with John Deere. One of the ag engineering graduate students actually did this work and provided me with their slides. So what they did was every 20 minutes, they went out and they pulled a manure sample from the applicator bar. We had a neat little knob set up. They could actually ride along the side of the bar on a gator, turn that knob, fill their collection container for that sample. And what they saw was nitrogen and P2O5 was actually fairly uniform in a pit that was agitated just prior to pumping. So this pit was agitated, and then when they started pumping, they pulled out the agitator so that the pump could go into that pump out hole. And the total nitrogen was fairly uniform, pounds per 1,000 gallons. Was running about 23 pounds per 1,000 gallons of total nitrogen. And then the K2O was also fairly uniform at about 18 pounds per 1,000 gallons. Phosphorus, on the other hand, which is our black line, and dry matter, which is our yellow line, changed rapidly. As soon as that agitation stopped, it took it a little over an hour to basically get to a flat bottom plateau. When they stopped agitating, it started out at a little over 25 pounds per 1,000 gallons, and by 60 minutes, it had dropped down to less than 10 pounds per 1,000 gallons. So looking at that, we're not going to agitate, we're only going to collect one sample. We were going to want to be down here, even though it's very wrong for that first hour, into that second hour to get our samples or collect. That's why we talk about collecting 5 time points along there, 5 different samples, so that we can get a good average and commingle those to send to the lab of what was really applied to our field. Because manure definitely is a variable nutrient and adds in variability. Stratification, when we talk about stratification, this is another set of samples that we're going to look at here, looking at nitrogen and P2O5. 5 different pits. Pits 2 and 5 were agitated during application, and then pits 1, 3, and 4 were not agitated. Pits 2 and 5, the consistency of both the P2O5 and total nitrogen definitely supports that use of agitation. So if we look at pits 2 and 5 here, as we come across the nitrogen, it's fairly uniform. It does trend down on both of those pits. And when we look at the P2O5, it's fairly uniform here on the yellow line, which is pit 5, and the black line, which is pit 2. Sorry about that. The one that's kind of an outlier is the gray one. Pit 1 is not agitated, but actually stayed fairly uniform, but it was a nursery pit and it was much more watery to start with. So maybe it stayed in solution better than the other pit. So pit 3 and 4, we see that P2O5 increases rapidly after about that hour point of right here would be your first hour at 3, second hour is at 6. So between hour 1 and 2, we start to see over here in the P2O5 a rapid increase in our unagitated pits, which is actually the opposite of the prior slide, which shows us that not all pits perform the same. There's some more pits in this study, and different pits perform very differently. And from working with growers, we don't have it all sorted out, but some of that has to do with the pit additives that they are using. To compare total nitrogen from those grab samples and lab results during that agitation, if the pit was agitated, each pit was slightly different, but agitation helps to keep those results of total nitrogen fairly uniform. So in this study, we have steer manure up here on the top red line. Moves around some. So again, we want to take multiple samples even with agitation, but it doesn't change a lot. And then we have hog manure. Total nitrogen bounces around and declines as we pump. Then when we look at that P2O5, we do have some noise in that hog manure. The steer manure is more uniform. But again, showing that need to collect multiple samples over the time of pumping. Last one here on pit variability, another set of pits showing the unagitated versus the agitated pits in the study, all put together on different graphs. So the 8 pits, 4 of each. We have the one unagitated pit that performs very differently. It is high in P2O5 and then drops off, where the other 3 are low and then spike. And we checked with the lab. It's not that the results somehow got mixed up and backwards. That's the way that pit was performing compared to the other ones. And it has that drastic drop. And that could actually be useful for us if we're tanking to know this. And that if we have that pit that starts low and then spikes, that spike is where we're going to be able to much more economically haul that manure further, or put it on the low areas in the field and use this weaker manure on those higher areas. With agitation, it's not as variable, but we do still see some variability, some differences between these pits. So pit 7, they stopped agitation after the first hour, and then it spiked and then kind of leveled off, which was strange. But there's still a lot of noise with that agitation, just not quite as noisy and bouncing as what our unagitated pits were. We're going to skip the questions and do those all at the end. Move into some record keeping. So with manure, there are some things that we're required to keep records on. We have to keep the name of the responsible agricultural fertilizer certificate holder, or the name of the CLM or whoever holds that manure application certificate if one is held. It's a little bit interesting that fertilizer certification may not be required if you just apply manure, but if you have that, you should include it on your manure records. Date and time of the application, month, day, and year. Location or field identification number of the manure application area. That location or field identification number really should be something that other people understand, not just the back 40 or the bin farm or whatever you call your farms. FSA field numbers are good, or a GPS coordinate to help better identify that field. Application rates in either gallons or tons per acre, and then the analysis of the fertilizer, or since it's manure, that analysis of your manure test. So in your record, you should write down the pounds per 1,000 gallons of N, P, and K that was applied, and then potentially reference whatever analysis number that sample results go with. Record your application method. Did you inject it into the soil? Was it incorporated after application? Was it just surface applied and left there? Soil conditions at the time: wet, dry, moderately dry, very dry, barely field conditions should all be recorded. And then we have to record weather data. Temperature, precipitation, other weather conditions at the time. If you're going to do a surface application, was the ground frozen or snow covered? All needs to be included in your application. And then not just write down what the weather is, but you actually need a copy of the weather forecast for the next 24 hours included in your manure records. Here's a sample record keeping form that's available through OSU Pest Ed. Nutrient.management.osu.edu is one of the places that's stored. They have a spreadsheet available too. You can work with, I'm sure, any of the water quality associates to help you find these, but it has everything you need, and each column would go with each field. And then the only thing you have to note is that 24-hour forecast, where it is and what it says. Just noting that it says it's a go isn't good enough. You do have to have that screenshot and saved. If you use your phone, that's fairly simple, or a computer, just save it in a file on your computer. So sources of weather information. Rachel's going to go into this a little bit more, and a tool that's available for record keeping. But one source of weather information is from OSU Bird Climate Center, and it's farm.bpcrc.osu.edu. And it's a fairly nice tool. It doesn't have all the record keeping features, but it's good for that climate or weather forecast for the next 12, 24 hours. It gives you red lights and green lights from the time you take that sample or submit that request for that fertilizer and manure application. So if you can't remember all the rules, it has those pre-programmed in for you. You select your field area, you can save all your fields, which makes it quicker to go back to. It gives you the next 3 days, the weather forecast. It has the date and time that was submitted. It does have a really nice feature. So if you check the weather and you forget to take that screenshot, you can actually go back in time. So we can go up to this view historical data and change it to the date and time that you started that application and pull and save that weather forecast so you have those records. If you make a mistake, and actually delete it off of your phone after you took the screenshot or whatever may have happened to it. Because in the letters and eyes of the law, it's not what actually happens, it's what the forecast said was going to happen. So we know that weathermen and meteorologists can be wrong. They can say it's going to be sunny and it rains an inch. So you need this record to show that it said it was supposed to be sunny when you went out and started that application. Another source of weather information is weather.gov. You put in your zip code, and then you can go down and get this 24-hour, hour-by-hour forecast. On this one here, we don't see any rain, so it would be good to apply, but we look over here under rain, we start to get a chance from the time this was pulled, which was September 28th at 9:23 a.m. On October 2nd, there was a chance of rain starting at 8 a.m. And then it would tell us how much as that chance of rain was there. And you just add those up for the next 24 hours to give you your go or no go on application. So the climate OSU site is a little bit easier to use because it gives you all that already added up and summarized. But this is another source you can use for that weather data. Any questions? As we move into Rachel.
Okay, let me get my screen shared here. And I'm going to go ahead and leave my camera off because I got an unstable internet warning earlier. Okay, can you see my screen?
Yep, looks good.
Perfect. Okay. So I'm going to talk a little bit more about record keeping. And in this presentation, I'm going to go through an actual example of some software that you can use to do your record keeping. So building on what Jason said. So we're going to talk about OnMark. So OnMark stands for the Ohio Nutrient Management Record Keeper. This was created by the Knox County Soil and Water and the Knox County Farm Bureau here in Ohio. And if you have your fertilizer certification, you know that OnMark can be used to track weather data and record any applications that you make, but it can also be used to keep records for CLMs. So go ahead and drop in the chat box if anybody is familiar with using OnMark, whether you've used it before, whether you've heard of it. If you are familiar with OnMark, feel free to tune out for the next 5 to 10 minutes because I'm going to go through the basics of it, setting everything up, and how to input your data. So setup is pretty simple. So first you have to register for an account or log in if you already have one. And you go to www.onmrk.com. You'll click register and fill out the required information if you don't have an account, which is your first name, last name, email, and then you have to create a password. If you have a certified applicator ID, you can put it in here, but it will let you create an account without one. And then you have to go to your email to activate your OnMark account from the link that they're going to send you. And then you're ready to go. So step 2 is to add applicators to your account. So applicators are individuals who will have access to this main account. They'll be able to add farms, they'll be able to add fields, and they can record applications for those fields. Each person has to have their own, they have to be their own applicator, so you have to add them. So after you select applicators from the top, you'll see your name down below because you created the account. And then you can choose to add additional applicators to this account to keep all your farm data in one place. And you do that by clicking this Add New button. When you click that, this is the screen that you will see. It just explains what an applicator is, and then you enter their first and last name, and that will give them their own applicator key. Now, the applicator key is very important. You have to have this in order to put in any kind of data from your smartphone. And without this key, the application data won't link back to the main OnMark account. If you forget this number, you can always regenerate it, but I have heard of individuals having issues with that. So it's always a good idea to go ahead and write that down and put it somewhere you're not going to lose it. So step 3 is adding your farms. You have to add at least one farm before you can start to add fields. So the way you do this is to select the Farms tab at the top and select Add New, similar to how we added an applicator. And then you can assign different fields to the farms once you add a farm. So after inputting at least one farm, you can begin to add fields. So you'll select the Fields tab at the top of the screen and then Add New, kind of the same thing we've been doing here. You can toggle which farm you want this field to be categorized under. So if you have Home Farm, you have Defiance County Farm, you have Paulding County Farm, you can select that and then add the field underneath that larger farm. You can put the acreage in and then latitude, longitude. And if you're doing this from the computer, you can go ahead and look that up on maps, or there's an option to actually put in farms and fields from the location that you're adding. So in that case, you'll be able to just use your location at the time, and we'll go through that in a few minutes. So then this field that you input is essentially what you'll choose when you input your applications that you make. So step 5 is actually inputting that application data. So when you go to the OnMark website, you'll see this My Applications page, and down below it'll have all of the fertilizer applications for all of your fields and essentially who applied that. So all the application data actually has to be put in from your phone or a tablet. So you can't put it in through the OnMark website, but you can edit the information from the OnMark website. So the list shown below this applications won't show anything until you make an application, which is why mine didn't say anything here. So from the app, when you first access the app, you have to sign in. And at the top of the screen, when you first open it and sign in, you'll have to select the settings and then change applicator key to input your unique ID. And as you can see here, there's weather data right there. It tells you the expected rainfall for the next 12 and 24 hours. So that also brings in another aspect of the record keeping requirement. So once you put in your applicator ID, you're good to go. And all the data that you put in from your phone or tablet will show up in the OnMark website. So from the app, you will select the farm that you wish to use. So in this case, we have home farm. And then you select the field. And then you can choose to let the app use your current location. So if you create a farm from the field or create a field from the field, you can use your current location, or if you're just down the road or if you're at your house, you can choose it on the map to make sure that that's accurate. And then once you click on your field, it'll show you all the application data for that field shown right there. And right now we don't have anything, so it says no applications. So the weather conditions are also shown for your location, and it also says at the top if conditions are acceptable to apply. So the day that I did this was September 23rd. It said conditions were acceptable. So you'll click Add New Application. You'll select the type of application in your start time, so you can toggle between manure or fertilizer. You'll use your manure analysis that Jason talked about to input your nutrient analysis in the soil conditions as well. And then you can choose your method, the amount per acre you used in your units. And remember, if you surface apply, you have to note if it's frozen or snow covered or incorporated within 24 hours. And then you can view previous applications to that current field, including the one that you just made. And you can see on that one, it says 2 minutes ago. You can also share those reports via email, and then that will allow you to download an Excel file or a PDF onto your computer or your phone for record keeping. So you can also download these records from the website. I will say it's much easier to download them from your app or to send them via email and then download them. When I used this, the CSV table that's supposed to be down below was not working for me. But it's designed for you to be able to download this straight from the website as well with all the same information. This is what the Excel file will look like once you download it. So it has every bit of information from that application. It has the weather data, has your analysis, the location, the name of the location, the type of application, and the person who did it. And from this Excel file, you can organize it however you want to. So thank you. I do have a teaching evaluation for this presentation, and I'll drop that link in the chat. So please go ahead and fill that out for me. It gives us valuable feedback about what we could do to prevent or to enhance our teaching. And we will take questions after Theresa. So thank you.
Awesome. Thank you, Rachel and Jason. Like Rachel said, if you guys have any questions, just drop those in the Q&A box and we will get those all answered at the end. I am going to share. Theresa, are you ready?
Yes, I'm ready.
All right, I'm going to get your presentation shared. And if you just want to let me know when you're ready for the next slide, we'll get it going.
Sounds good.
All
Okay.
Right.
So I'm here to talk about manure nutrient recovery and some of the technologies that are available currently and some of the research that we've been doing in Mercer County. So if you want to advance to the next slide. So I guess why are we talking about manure separation and treatment? Mercer County, if you're not familiar, has a lot of livestock, mostly small to medium-sized farms. And then a lot of our larger farms are actually poultry manure. Where the poultry manure is brokered and well distributed across the state and Indiana as well. So we also have high soil test phosphorus on average across the county. That's obviously not every place, but that's a total average. So we really have a need to better distribute phosphorus in particular from manure and get that more widely distributed in an economical fashion. So you know, we have done a lot of work here because of Grand Lake St. Mary's and the issues that we've had. Ag Solutions Group was formed in 2011 to look for solutions in agriculture to improve water quality. And this has included the manure management along with other best management practices. Next slide. So after being involved with this research for several years, we found that most equipment and chemical processes that are recovering nutrients from manure, that they all work. But the problem is, what do you want out of it and how much are you willing to spend? So most of the time, these nutrient recovery mechanisms are not necessarily cost effective, especially for small to medium-sized farms. And we have to consider both the upfront costs, the capital costs, and we have to consider the continuous operational costs of these systems. Next slide. So renewable natural gas has been a really hot topic recently, and you can go ahead and click through, I think, 2 more. The point of this slide is just to show that there's been a ton of emphasis on renewable natural gas, particularly because of the intensity of carbon and capturing carbon and federal subsidies involved with doing so. So there's several larger farms investing in renewable natural gas, primarily through anaerobic digestion. So go ahead and move to the next slide. So anaerobic digestion is definitely the most popular method of capturing the energy in manure, but there are also other processes that can do this as well, such as gasification, hydrothermal liquefaction, and simply covering anaerobic lagoons. There are, as I mentioned, a lot of federal subsidies involved with renewable natural gas and carbon reduction. And there are a lot of developers out there offering different options for farms. But not all of these processes or developers are created equal. So the biggest thing is understanding the size of your farm, your limitations. Typically, we're seeing digesters put on larger dairy farms. It's not typically suitable for a 200 head dairy. And we don't see a lot happening in the swine industry as well. Next slide. But we also need to consider that anaerobic digestion alone is not enough, especially for considering the nutrient implications of that, because a pound of phosphorus into a digester equals a pound of phosphorus out. Now, over the last several years, these digester companies have really taken a hard look at nutrients and looking at ways to recover a lot of those nutrients after digestion. But initially, I want to say 6 years ago, the model was, if we had a centralized facility that was servicing several farms, if you brought a truckload of manure in, you would have to take a load of digestate back. That doesn't really work with what we're trying to do here in Mercer County, which is move phosphorus out of the watershed. So anaerobic digestion alone does capture methane and reduce carbon emissions, but we really need to focus on the nutrients. So is the company recovering the solids from the digester? And what about the nitrogen in the effluent? Because typically, anaerobic digestion is going to settle out the phosphorus in the solids, which are somewhat easier to recover, but you still have a high amount of nitrogen in that effluent, which is your limiting factor on application of that effluent. So we've been really working on trying to find ways, not only after anaerobic digestion, but with raw manure, to really harvest those nutrients out and create a valuable product that could be sold. Next slide. So that brings me to a company called Barger Tech. I'm sure many of you may have heard of Barger Tech and what they're proposing to do in Ohio. So they are proposing a facility in both Wayne and Mercer counties to process manure. They're using a form of hydrothermal liquefaction and not anaerobic digestion. And then they're going through a full wastewater treatment where they will create several products, a separate nitrogen, a separate phosphorus, and a separate potassium product. So in addition to that, after they go through the hydrothermal process, they'll have our renewable natural gas, biofuel crude product, and a carbon amendment, which is a solid carbon product with a 555 analysis. So next slide. what I like about Barger Tech is it is offering a solution for farms of all sizes. So they're willing to sign up 200 head dairy or all the way down to, you know, a 20 head dairy. And they're also willing to take swine, poultry, all types of manure. They're offering a 10-year contract to these producers, and the farmers get paid per dry ton of manure delivered to the facility. The other thing I really like about what they're doing is they are investing a lot in detailed nutrient management on their partner farms. So they're looking at what the nutrient needs are for those farms based on their soil test levels and making sure that they're only getting back the nutrients that are needed on that farm. And then the goal is the rest of those nutrients will be sold as commercial fertilizer out on the market. The other advantage is they require no investment from the farms. So everything that's done on farm and at the centralized facility is at their cost. But, you know, there's some inclination that sometimes something like this is too good to be true. So we'll believe it when we see it constructed. So next slide. Gasification is another way to harness the energy in manure. It basically is converting the manure at a high temperature with a controlled amount of oxygen into gases and biochar, which creates your renewable natural gas. And then biochar is basically another carbon amendment product. These are expensive machines. However, there is one in Ohio on the Ohio heifer facility and one on Indiana on a swine and poultry farm. That farm over there in Indiana, basically they are using livestock water recycling, which I'm going to talk about a little bit later as another technology to separate the swine solids. And then they gasify those swine solids along with the poultry manure, which I think is predominantly turkey manure, and the mortality as well. So it's an interesting process. Again, it's got a very high capital cost and also somewhat high operating cost. Next slide. We've looked at centrifuge. In fact, we piloted a centrifuge in Mercer County in 2016. They're a very efficient machine that can recover up to 70% of the phosphorus in liquid, in this case, swine manure that we piloted. Liquid swine manure, we're able to recover 70% of the phosphorus without any chemicals used, just using the machine. And then we were able to get 90 to 100% of phosphorus recovered into the solids using polymers in this case, in this project. However, these machines can be pretty finicky. They need to be level, and from what I understand, those that do operate some can be maintenance heavy. So it's one of those that it's also fairly expensive. I think the smallest unit, last I heard, was around $250,000 for a machine that would do 25 gallons per minute. Next slide. Digested organics is a really cool process that uses anaerobic digestion followed by ultrafiltration. And then they have an option of even going all the way to clean water using reverse osmosis and disinfection. They do have a installation in Sheboygan Falls, Wisconsin. I actually visited the farm a few years ago. It's, like I said, very cool process because it requires no chemical addition to the manure. But it takes a lot of space, and it's expensive. And the other slightly downfall is, so you create clean water, you can get, so if you're putting in 100 gallons of manure, you can get about 70 gallons, up to 70 gallons of clean water out of that. But then you're left with a pile of solids, which are going to be low in nutrients, and then a very concentrated liquid manure left that still needs to be applied. So still, that super concentrated product isn't necessarily easily transportable because it's still in that liquid form. So we've looked at ways to try to integrate this into a centralized facility. We just haven't quite found a way to make that work yet. Next slide. Livestock water recycling. This is actually a quite popular manure nutrient recovery technology across North America. They're based out of Canada. They have a large installed base of their systems. But the picture here you see is a sloped screen that's primarily their separation, but they are using polymers to get a good majority of the nutrients into the solid form. And then they also offer an option of going all the way to clean water using reverse osmosis and disinfection as well. I did visit 2 locations of installs in Indiana. One is no longer in use, and the second one was a fairly new install, and they were still working out the bugs. So I'm not sure if that's still operating, but the farm that had installed it years ago and was no longer using it reported a lot of maintenance issues, and it couldn't meet their capacity required to keep it running. They just couldn't put enough flow through it. So there are issues with all these systems. Next slide. Trident processes, again, a really nice technology that's used at Fair Oaks Dairy in Indiana. As you might know, Fair Oaks uses anaerobic digestion for all their manure. They are a very large facility, but what Trident process is doing is taking that liquid that comes out of the digester and putting it through dissolved air flotation using polymers. And then that float that comes to the top of the dissolved air flotation device is dewatered further using a multi-disc screw press, which you see in the picture there. It's very, very efficient on that large of a farm. You're talking 30,000 cows. So that large scale, it is very efficient. And they're working with a company called Midwestern Bioag, which turns all that solid product into value-added products, which you may know as Terrenew products. Next slide. Manure pit additives. I've done a lot of research on these. So when I first started in my role here in Mercer County, I had a lot of salesmen selling pit additives, knocking on the door. You might call it bioaugmentation of manure, and you can see some of the things listed that we've looked at. You know, a lot of these salespeople came in selling that they were going to reduce nutrients in the manure, which we all know that that's not really something that you can do, especially with phosphorus. Phosphorus does not volatilize like nitrogen. So really, if it's in there, it's going to stay in there unless you take it out. So we did a lot of studies with them, and there are definitely good uses of manure pit additives. But what we found through all that research is it really does make the nutrients more plant available. So we saw a lot of the organic nitrogen and a lot of the organic form of phosphorus, or the solid form of phosphorus, go into a more dissolvable form. So it really increased that nutrient availability of nitrogen and phosphorus. So that really creates kind of an issue. If you're using manure pit additives, you want to make sure that you're applying those nutrients to a growing crop or very close to a growing crop. You don't want to be putting manure that's been treated with a manure pit additive out in the fall with no growing crop, because more than likely you're going to lose those nutrients. And when those nutrients are more in that dissolved form, they're going to fuel those algal blooms even more than what we would have started with raw manure. But there are certainly benefits of manure pit additives. You know, you reduce solids on the bottom. So if you've got a problem with that, it's going to help with that. And it's also going to help reduce crusting. I don't see a whole lot of odor benefits, although they'll claim that they have odor benefits, but they're not substantial, let's say. Next slide. So now I want to talk on a process called quick wash. This is one that I've continued to research, and we're trying to find a solution to make quick wash, along with a few other things, fit into a solution for farmers of small and medium size. And we've been really focused on swine manure because there's not been a lot in the swine industry to really help solve this nutrient problem and get these nutrients further further utilized and better distributed. So quick wash is a USDA patented chemical process that uses lime and acid. So basically what's happening is we're adding a little bit of acid to the manure, and what that does is forces a majority of that phosphorus into solution. And the reason we're doing that is we're going to add lime to precipitate that back out. So we're trying to capture as much phosphorus as we can with that lime to create a calcium phosphate product. You want to move to the next slide? So it takes several steps. You can't just take a pit of raw manure and add acid and then add lime. It doesn't work quite like that. First and foremost, you need to screen out a lot of the big solids. So when you're thinking swine manure, you know, the hair and the grit and everything that's in the pit, you need to screen that out. Same with dairy, you're getting out a lot of those large fibers. So for that, we've used a KDS separator, which is a multi-disc lobe machine that's just a simple separation machine. Doesn't require polymer to get out those large solids, but you can use polymer if you would want to. And then it's got a very low energy demand. So it's a very small machine and simple design, so it's quick. So we're using that as our first step in the quick wash process, is we're taking it through that KDS separator. And then that effluent that comes off of that, that liquid, is what we're using through the quick wash process. Next slide. So here's some of the results over the trials that we've done over the last several years with quick wash. So you can see the content of the raw manure. You know, we're starting with a typical swine manure that we see. And then you can see the filtrate after it's gone through the entire process. And you can see that we've recovered, on average, across all of our trials that we've done, about 96% of the phosphorus into the calcium phosphate form. So the one issue that, you know, we're still working on is, so you have a pile of solids that comes off your separator in the front, and then you're putting it through quick wash, and you still have a slurry of calcium phosphate. So you have to put that again through another process to get that into a solid form. So we've tried things like geotube bags. We've tried several different mechanical pieces of equipment. The picture here you can see is a multi-disc screw dehydrator. So that's a series of discs with a screw in the middle of it. And basically it pushes that manure through and gives you a nice cake at the end. It does require the use of a little bit of polymer to make sure that you're being efficient with it. But the ultimate goal with this whole KDS quick wash and then dewatering process is to find a solution that's somewhat affordable. And we continue to work on a way to mobilize this. So if it could be a trailer that comes onto the farm and processes somewhere to the tune of 100,000 gallons per day. So it could roll up to a farm, process manure for a couple days, and then leave. The goal is to resale the calcium phosphate onto the market. The good thing about quick wash is they're also starting to look at ammonia recovery. So they are recovering ammonia sulfate through the same quick wash process, but they can also use a different acid type to get ammonium citrate or ammonium sulfate. So we're continue to work on this, and interesting to see where it goes here in the future. Next slide. There are also other various types of presses and separators out on the market. Farms are using them all the time. There's screw presses and vibratory screens, slope screens that you can see in the picture. And again, the multi-disc press, there's more and more of those multi-disc press out on the market now. But the important thing to note is you can use these to remove fiber, particularly from dairy manure. You can remove fiber very efficiently. But if you're not using polymers, you're not going to capture a lot of the phosphorus. So yeah, you're taking out some of the organic material in a solid form, but most of the phosphorus is going to go through the liquid portion after using these types of separators without any chemicals. Next slide. So this is a mobile treatment unit in Pennsylvania that USDA is continuing to develop. It's using a similar type concept, where they're doing a solid separation followed by a treatment to really harvest as much phosphorus out of the manure as they can. So this is similar to what we would like to do with that quick wash process, is where it could pull up to a farm, process manure, and then have a pile of nutrients that could be resold. I'm working with a company to try and really work on the market to resell these nutrients and to provide this mobile service. Next slide. And of course, manure composting is a great way to consolidate nutrients, get your manure a little bit drier. It is time consuming and it does take a lot of space. This is a farm in Mercer County that's been doing it for years. It's a dairy farm, and they've got manure of all sorts, a little bit of liquid from the milk house and runoff. And then they've got heifer manure and the dairy manure, but they are composting about 70% of what's generated on the farm. And it's a great product. So manure composting is really a great old technology that still works really well if you're willing to put in the time and the effort. Next slide. So in conclusion, these are just a handful of the technologies that are currently available on the market, but the point is that it needs to be simple, affordable, and effective, especially for these small to medium-sized farms, because they just don't have the manpower or the time to manage manure in a new fashion. It works on a lot of these larger facilities because they've got large facilities, large amounts of manure, and it makes sense. But we're looking for these solutions for not only smaller dairy farms, but the swine industry as well. And we want to try to see if NRCS could cost share on at least some of the infrastructure that's needed, whether it's a building or another liquid storage facility or a dry storage facility. And we continue to work on these partnerships to market these manure nutrients. So obviously different areas of the state are going to call for different solutions. It's not a one size fits all solution. Obviously in Mercer County, we're a little bit unique with our livestock density and our issues with Grand Lake St. Mary's, but we think that what we find here is going to be useful across the state and across the nation. So I believe that's it. My last slide has got my contact information. If anyone ever has any questions, please feel free to reach out to me. And I guess I will turn it back over for any questions.
Awesome. Thank you so much, Theresa. So like Rachel said, if you guys have any questions, please put those down in the Q&A box. I'm also going to open up a poll, and if you need the CLM credits, if you could just vote yes on that poll, that would be great so we can get those in for you guys. Jason, I'm going to start with a question for you here. How often do we need to conduct that manure analysis, and how often should we be calibrating the spreader?
Yeah, so your manure analysis, you should really take a manure analysis every year. And some people keep those as a running average and add that to their sample or their line and create an average to try to get a more accurate sample. And other people take it every year and just use that. If you know about the ration changes, changes in ration is what greatly affects that manure analysis. Or if you are in a pin pack situation and you change your bedding source, that can also affect that manure analysis. So knowing a little bit about that, the ration that's being fed can help you determine how often to take those manure samples. But taking one yearly and kind of creating a weighted running average can work well for that. When it comes to calibrating your manure spreader, consistency changes in manure is going to change that calibration. So a manure that is packed tighter together will have a different calibration than manure that is fluffy. Or if you change ground speeds, can also affect that calibration or apron speed on that manure spreader. So probably checking that once a year to make sure that it is still calibrated and you're using the same ground speeds or the same apron speed and nothing has changed there. Is probably what you need to think about. Changing tractors on the manure spreader, if it's hydraulic driven, could also change that calibration.
Awesome. And then Jason, one more question for you right now. Is there a way to determine the manure nutrient analysis for pastured beef?
If you want to, you can determine the manure analysis, but not the urine portion, unless you're going to somehow collect both of those. You can there's some different tables and charts out there to calculate about how much an animal should be producing. And then if you wanted to sample some fresh patties, you could get an idea of what the solid portion is of that manure by submitting those into the lab for analysis. And then using those tables to kind of determine how much on average an animal would be producing.
Awesome, thank you. Theresa, I've got a few questions for you. Are there any options for manure treatment that may be cost effective for smaller herds? If not, are there any that are on the horizon?
Yeah, that's the ultimate goal of what we're doing, is trying to find something that is cost effective for the smaller herds, like that mobile unit that could, travel onto the farm for a few days, harvest nutrients, and then come off. Along with, the Barger Tech solution obviously is for farms of all sizes. I know they would like to expand throughout Ohio if they're successful in Mercer and Wayne counties as their first 2 locations. But for a small farm to invest in the equipment, it's just simply not there yet, unless we can offer, more of a community type solution.
Awesome. And then just a few more questions for you. How is manure transformation and use both profitable for the companies doing it and economical for the farmers utilizing it?
Yeah, so that's where the resale value of the nutrients really comes into play. And working with, some sort of fertilizer dealer to really put those out on the market. So that's where it's going to profit both the farmer and that company reselling those products. If 40% of the phosphorus that's applied in Ohio is coming from the mines in Florida as commercial fertilizer, I really think that we could discontinue the use of that commercial fertilizer and reuse it as better distributing nutrients that are already generated in Ohio and in places like Mercer County where we're livestock heavy, and just better utilize what we're already creating through manure and or biosolids, things of that nature. Even they're starting to look at harvesting algae and utilizing phosphorus that's harvested from algae after it's gone through a stabilization process, like, the thermal processing. So I think there's a lot of opportunity on the horizon, and there's more emphasis on it now than I've seen in the last 6 years.
Awesome. And I've got one last question for now. And if you guys have any other things, feel free to put those in the chat box. Do you see these processes becoming mainstream in animal agriculture in the next 10 years?
Yeah, I do. Definitely, I would say within the next 10 years, probably even 5, we're really going to see more and more emphasis on anaerobic digestion and a lot of the harvesting of the energy in the manure. And then it really seems as if we're getting to a point where nutrient recovery is going to be a part of that process as well. So I would say for sure in the next 10 years, it is going to be part of manure handling.
Great. So it doesn't look like we have any other questions right now. If you guys have anything, please feel free to put that in the chat box. If you guys need your CCA credits, you can scan this QR code here and you'll be able to get those. Oh. And I will leave that up so you guys can see it. Can you guys still see that screen? Or did it close?
It closed.
Let's do that again. Can you see it now?
Switch your presenter view.
Mm,
Display settings at the top there.
There you go. And just some other updates. I will leave that CCA credit code up there. Our water quality Wednesday dates are January 25th, February 22nd, and March 29th. We will be sending out some flyers for that. And then our next CLM webinar is going to be on December 5th. So keep an eye out for, oh, it's still, let me try and share that. And then I just stop it. Is it good now?
Yep, that's good.
All right. So be sure to look out for the email or flyers for those with some more topics and things like that. And thank you guys for joining us today. If you guys have any questions, feel free to email any of our team members on the webinar, or if you have any questions about upcoming webinars. Like I said, please join us December 5th for our next CLM webinar, and the recording from today's will be posted on YouTube, and you will also receive an email afterwards with the link to that recording.
Also, if anyone has any suggestions for future topics, feel free to email anyone from the team, or you can email waterqualityassociates@osu.edu, and that will reach all of us. I will drop that in the chat right now. But again, if you have any kind of suggestions for topics you'd like to see, please send those our way.
Thank you everyone for coming today. That is all we have. You guys enjoy the rest of your Monday and the rest of your week.